Hi everyone, welcome to NCKHUB. Today in our video we are going to cover COMSORT as part of data structures and algorithm. Yeah, we'll see first what is COMSORT and what is its algorithm, and we'll see one sample example how it works, and we'll see the implementation with Java programming language. Yeah, what is COMSORT? So COMSORT is like an advanced form of bubble sort. So in bubble sort, we compare the all the adjacent values. Whereas in COMSORT, it is going to remove all the turtle values or small values near the end of the list. So it is COMSORT is going to improve the bubble sort by using the size gap more than one. So gap is going to start with the larger value and then goes on, or like it is going to shrink by a factor of 1.3, and this iteration goes till the gap is 1. So by the time it comes 1, so our required array will be sorted. Yeah, next we'll see what is its algorithm. Yeah, so here we are going to take the input parameters as like array and the size of the array. So here we are going to initialize the gap with size of the array, and the shrinking factor is like 1.3, and if swapping is required, so that we are making it as true. So first gap is not equal to 1 or swap equal to true, then we are finding the gap. So how we are going to calculate the gap is like floor of gap by 1.3. So if gap is less than or equal to 1, so we are making the gap equal to 1 and we'll return it. Otherwise, we're going to swap. And now the iteration. So how the iteration goes? So it is going to compare the first element and then whatever the gap we are getting here. So we are going to compare the elements from that position. So if the current element is greater than the gap element, like we are going to swap the elements and we are going to make that swap as true, and that's how it is going to iterate loop. And then we are going to end this for loop, and we are going to end this for loop. So this while loop is like yeah, gap size till it reaches 1, so that is the while loop, and we are going to stop this console. Yeah, next we'll see the one working example. So here I'm taking the elements of array like 49, 11, 24, 44, 29, 27, 2 and 22. So now here I'm going to initialize the gap size like size of the array. So that is equal to gap equal to 8, and then shrinking factor is 1.3 and swap true. So first iteration we are calculating the gap. So it is floor of size of the array is 8 by 1.3. So I am getting the gap size as 6. So with this 6, I am going to compare the elements of those particular positions. So yeah, first we'll see iteration, first iteration with the size of gap of 6. So we are going to compare the element 49, and then you can see 11, 24, 0, 1, 2, 3, 4, 5, and here the sixth position is 2. So now I'm going to compare these two elements. So here 49 is greater than 2, so swap is required. So I'm swapping the elements. So 2, now this is the order 2, 11, 24, 44, 29, 27, 49, 22. And then so the next I equal to 1. So the element we are going to compare is index 1 and the index 8. Okay, sorry, index 7. So 11 and then 22. So 11 is less than 22, so no swapping is required. So next iteration I equal to 2. So now we are going to need to compare the element at the 8th index. So there is no 8th position in the array. So this gap of 6 iteration is going to end here. So after this is the order. And now coming to the second iteration, so we are going to calculate the gap. So gap, so now gap is 6 by 1.3, so we are going to get the gap of size of 4. And yeah, so last there is no swap, so we are making it as false, and then proceeding to second iteration. So here we are going to compare the elements with size gap of 4. So 2 and 29, so no swapping is required, and 11 and 27, no swapping is required, and then 24 and 49, no swapping is required, and then 44 and 22. So 44 is greater than 22, so swapping is required. And then so next iteration value will become 4, 4 plus gap size 4, and there is no eighth element, so iteration ends here, second iteration. So after second iteration, so this is the order. And coming to third iteration, so again we need to calculate the gap. So floor of 4 by 1.3, so it is 3. And now we can see iteration, so we are going to compare elements with gap size of 3. Okay, 2 and 22, so there is, so 2 and 22 is less than 22, no swapping is required. 11 and 29, so no swapping is required. So 24 and 27, so it is already less than, no swapping is required. 22 and 49, no swapping, and 29 and 44, no swapping is required. So that's how iteration ends here. So iteration 5 plus 3, 8. So no element at the 8th position, so iteration ends here. So next is fourth iteration. So again we need to calculate the gap. So floor of 3 by 1.3, so it is 2. So now we are going to compare with 2 element gap. Okay, so 2, 11 and 24, so 2 is less than 24, no swap, and 11 is less than 22, no swapping. 24 less than 29, no swapping is required, and 22 less than 27, no swapping, and 29 less than 49, no swapping is required. 27 less than 44, no swapping. So here iteration, so I plus 6, 6 plus 2, 8. So there is no element at 8th position, so iteration ends here. So next we will go to the fifth iteration. So their gap size equal to 2 by 1.3, so that is 1. Now we are going to compare adjacent elements. So 2 and 11, no swapping is required. 11 and 24, no swapping. 24 less than 22, swapping is required. So element become 22 and 24. So again we are going to compare 24 and 29, so no swapping is required. And then 29 and 27, so again 29 is greater than 27, so swap required elements 27 and 29. And compare 29 and 49, so no swapping is required. And then 49 and 44, so no so swapping is required. So after swapping, so this is the final sorted array. So before going to the time complexity, so we'll see the sample implementation with Java. So this is the sample programming. So here first I'm creating one class consort demo. So here I am initializing one array with all these elements 43, 39, 13, 42, 27, 25, 0, 4, 8. And then I'm calculating the length of the array. And before sorting, so I'm just printing the array elements using this method, and then calling this comsort method. And after sorting, so I'm just printing the elements. So yeah, in comsort, so first we'll see display. So here I'm just iterating the array and then printing each element. And here, so next is comsort method. So here we are calculating the gap and doing the while loop iteration and the for loop iteration. So first we are initializing the gap with the length of the array, and then swapped we are initializing with 1. and we are going to the while loop. So gap not equal to 1 and swapped equal to 1. So we are just calculating the gap size. So for this we are creating one more method, update gap. So gap we are passing the parameter as the size of the array. So 8, so update gap of 8. So we'll go to this method. Here we are just calculating. So gap into 10 by 1. So ideally it is 1.3. Since we are doing it with int, so we are just multiplying with 10 and removing the decimal 13. So that's how we are calculating the gap using this method. So if gap is less than 1, we are returning 1. Otherwise, just return the gap. So once we get this gap, we are doing the for loop iteration. So this is my for loop, and here I am comparing the elements of the current and the whatever gap we are getting. So I plus gap. So like this, it is going to compare those indexes elements, and if current element is greater than that gap element, so we are creating one temporary variable and copying that current element and then swapping these elements. So yeah, so that's how we are initializing this, sorry, creating this comsort method. So now we'll run this. Okay, so yeah, so here we can see, so before sorting, so these are my elements, and after sorting, so all the elements are arranged in ascending order. So here we can see how the gap is increasing, now decreasing to 1. So first is 6, so 8 elements are there. So size of the array is 8, 8 by shrink 1.3, so that is 6, and then 6 by 1.3, that is 4, and yeah, 4 by 1.3, that is 3, yeah, and 3 by 1.3, that is 2, and 2 by 1.3, that is 1. Okay, so yeah, after this we are going to get the sorted order. So now we'll see like how it works by uh, each gap size. So how the elements are changing its positions. So now run this. So for each gap size, so we can see the iteration. So yeah, 43 and gap size is 6. So you can see 43 and 0. So iteration 0, so those two elements got swapped, and iteration 1, 39 and 4. So again those got swapped, 4 and 39, and after that 13 and 8. So again those 13 is greater than 8. So those two elements got swapped, 8 and 39. So that's how gap 6 while loop completed, and then next calculate the gap size. So gap, so it is 4, and again for loop iteration, so here it is going to compare element with 0 and 27. So yeah, so here you can see, yeah, finally 13 and yeah, 27 and 13. So these two elements got swapped, and similarly for each gap size, like we can see the iterations and how the elements are changing its position, and with size of gap 2, and we can see gap 1, so we have many iterations. Yeah, so by this time so we already got the sorted elements. Okay. Yeah, now coming to the time complexity. So in case of best case complexity, like no sorting is required, so that's the time. So it is order of n log n, and in case of average case complexity, it is order of n square by 2 power p, like where p is the number of increments, and in case of worst case, it is order of n square. And coming to the space complexity, like we are using one temporary variable like to swap the elements, so that is order of 1. Yeah, so that's how ComSort works, and thank you for watching the video.